Hello, in this video I'm going to show a tutorial demo about a tool to emulate business processes in order to test their functionality and performance. The tool is benefit from the potential of a spreadsheet to set up the emulation of business processes and also to test the process performance and functionality. As part of the solution, we provide a Google Spreadsheet template that contains 3 sheets. Let's start by looking at the first one, in which is placed the image of the process model. The second sheet is used to configure the emulation of the process by setting up properties of the emulation such as the number of instances and the instances arrival rate, as well as process variables. Additionally, the functional property of the process task, such as the execution time, can also be configured. The value of each input property can be specified by using constant value or mathematical formula supported by Google Spreadsheet functions. In the third sheet, we will show the results of the process emulation. After this review through the template, let's go back to the first sheet that shows an image of a very simple process which I am going to use in this tutorial. The process starts receiving a request for a credit loan, indicating the name and email of the requester with the request amount and the salary of the requester. Then, the request is checked, and if the amount requested is more than the half of the salary, it is rejected, notifying the requester. Otherwise, it is accepted. Now, let's configure the process to emulate. First, we need to indicate the number of times we want to emulate the process. Second, we introduce the rate in milliseconds by which the instances will be created. Third, let's configure the process variables. To do so, we can use, for example, constant value for the first two properties, name and email. Then, let's introduce the value of the salary, which can be a value modeled by a conditional function. In the same way, we can set up the value of the loan request amount, indicating that it can take random values from 350 and 1,200 euros. Finally, let's configure the execution time of each process task. In the first case, we can use again a constant value. In the second case, we can apply again the random function. While in the case of the last property, we can use a more complex statement by applying a combination of two functions, the standard deviation and the random. When all the process input variables and emulation parameters are configured, we are ready to run the emulation of the process by clicking in Run Emulation menu item. Then a little window is displayed in the lower right corner indicating that the emulation of the process is running. At this moment, the emulator deploys the process using a workflow engine and executes the process the number of times indicated in the emulation configuration. Evidences of the process execution are registered by the emulator during the process execution. Later, when the emulation of all instances finish, an alert is shown to the user indicating this. When the user clicks OK, the results of the emulation are shown in the emulation output sheet, where we can see a first column indicating the number of the instance, then the value of the properties in each instance, and later the value of each output variable of the process, in this case just one output variable that indicates if the loan request was accepted or rejected, and finally the execution time of each task involved in the process. From this moment, the user can define metrics and assertion formulas to analyze the performance and functionality of the process. Let's create a new sheet to define metrics in order to analyze the performance of the process. As an example, we will show a metric to evaluate the speed of the process. To do so, we will calculate the execution time of each instance, using a basic mathematical formula to sum the execution time of each task. In order to get the execution time of the task, we can refer the cells of the emulation output sheet that contains them. Later, we define the formula for the metric, in which we state that the instances with an execution time below a defined threshold perform with a slow speed, while the instances above or equal to the threshold perform normal. Then, we can calculate the total of instances with a normal speed and the total of instances with a slow speed. Finally, we can create a pie chart to illustrate this final calculation. In addition to the metric definition, we can test the functionality of the process task by defining assertion formulas in the same way we have defined the metrics. As an example, we have created previously a sheet with an assertion formula that tests the correct functionality of the task that checks if the credit loan can be accepted.